In this lesson, we'll cover systems of linear equations. What are they, and what does it mean to be a solution of them? So here we have two linear equations, x plus y is equal to 5, and y is equal to 2x minus 1, and if we consider these together, we call it a system of linear equations. Now, to be a solution to this system, it's going to be any point xy that makes both equations true at the same time. So I have a couple of questions here. Is the point 1, 4 a solution to this system? So here my x value is equal to 1 and my y value is equal to 4. And what we can do is take this information, plug it into both equations, and see if it makes them both true. So for the first equation, that was x plus y is equal to 5, I think it works here because 1 plus 4 does in fact equal 5. So that's good. So the point 1, 4, it worked for this equation. If it works for this one too, then we have a solution. So let's try that one. The second equation is y is equal to 2x minus 1. So I'll put 4 in place of y. I'll put 1 in place of x, and this doesn't look good. This is 4 is equal to 2 minus 1, or 4 is equal to 1. I mean, that doesn't work. That's false. So what this means is the point 1, 4 a solution? No. It did work for the first one, but it didn't work for the second one, and it has to work for both. Now, what about this point, the point 2, 3? Again, the way to solve this is by plugging it into both equations. So starting with x plus y is equal to 5, is 2 plus 3 equal to 5? And the answer is yeah, because 5 is equal to 5. So here, x is equal to 2, and y is equal to 5. If we try that in the second equation, y is equal to 2x minus 1, we'll put 3 in place of y. We will put 2 in place of x. And is 3 equal to 4 minus 1? It is, because 3 is equal to 3. So the answer over here is yes. The point 2, 3 is a solution to this system of linear equations. Now, is this the only solution? Are there others? Let's examine this a little bit further on the next slide. So here I have the same system, x plus y equals 5, and y is equal to 2x minus 1. And down here, I actually graphed both of the equations. The one in red here is x plus y is equal to 5. And the equation in blue is y is equal to 2x minus 1. And one thing to notice on the graph is that they intersect. They meet right here. It has an x value of 2 and a y value of 3. And we saw in the last slide that the point 2, 3 is a solution. So one way to think about a solution to a system of equations is, if you graph them, any place where they intersect is a solution. So looking at this picture, these two lines will never meet again. They meet in this one spot and this one spot only. So 2, 3 is a solution. In fact, it is the only solution. So let's make note, it is the only solution. There's only 3 possibilities with a system of equations. There's exactly one solution, there are no solutions, or there's infinitely many solutions. One way we can see this is by using something called the substitution method. Certainly you could graph your equations and try to see the point where they meet, but if you don't have a graph, there is another approach, and here's how it works. What we can do is take one of the equations and plug it into the other. So I see that I have x plus y is equal to 5 and y is equal to 2x minus 1. Well, I'm seeing that, y is equal to 2x minus 1. And I can take that and plug it in place of this y. And what this will do is reduce 2 equations down into one equation with exactly one variable. Here's what that will look like. Instead of writing x plus y is equal to 5, we're going to write x plus, y is really equal to 2x minus 1 in our second equation, but that is equal to 5. So here, I substituted one equation into the other, reducing 2 equations down into one. This brand new equation has exactly one variable in it, and that means we can solve this thing for x. Let's see what happens if we do that. I don't need those parentheses, so I can just write this as x plus 2x minus 1 is 5. On the left, I can combine variables. X plus 2x is 3x. If I add 1 to both sides of the equation, I get that 3x is equal to 6. And if I divide both sides by 3, we get x is equal to 2, which, by the way, that is the x value. We don't have any other x value. That means there is no other x value that can work for both of these equations. Now, what's the corresponding y value? I mean, I know it has to be 3, but the way you can figure that out from here is by taking this x value, putting it into any of the equations that you want. I say we put it right in place of this x, and we can use that to solve for the y value. So y is equal to 2 times, well, the x value was 2, and we subtract 1. So that's 4 minus 1, and that is 3. And, no surprise, that is the corresponding y value that we have up here. So the substitution method is nice because what you can do is not use a graph or a guess and check approach, but you can take one equation, plug it into the other, and then solve that equation for, in this case, x. So let's try this in example 1. I want to use the substitution method to solve this system of equations, and let's see if we actually find a solution. There are multiple ways to solve systems of equations, but I'm going to choose what I think is the simplest. And here's what I'm noticing. This equation is already solved for x, and I'm seeing an x right here. I can take 2y minus 10, put it in place of this x, and I'll have one equation with one variable in it. So that is, I'm taking this x, I'm going to plug it in right here, and I'm going to solve the resulting equation. My brand new equation is 2, but not x. I'm going to write 2y minus 10. That is equal to y plus 4. I just took two equations, plugged one into the other. It's now reduced down to a single equation, and it has only one variable in it, only y's, no x's. To solve this thing for y, I'm going to distribute the 2 and combine some like terms. By multiplying in the 2, we get 4y minus 20 is equal to y plus 4. Turns out everything is simplified on the left and the right, so I think what I'm going to do next is subtract y from both sides. This gives me 3y minus 20 is equal to 4. I can then add 20 to both sides, and I get 3y is equal to 24. And then if I divide both sides by 3, I've solved for y. Y is equal to 24 divided by 3 is 8. Okay, so that's the x value. So in finding my solution, I know it's going to be something comma 8, but I need to know what the corresponding x value is. I can now go back to, let's say, this equation here, put 8 in place of y, and solve for x. So x is equal to 2 times 8 minus 10, which is 16 minus 10, or simply 6. In this process, I found exactly one y and exactly one x. That means there is only one solution to the system, and that solution is the 0.6 comma 8. Let's go over a second method to solve systems of equations, and it's called the addition method. So here in example 2, I definitely have a system of linear equations, and I want to solve for the point or points that make it true. Now, I actually don't think using the substitution method is a great idea here. And the reason for that is, if you want to solve these equations for either x or y, you're going to have to introduce some fractions, and I think it's going to be kind of a mess. But I'm noticing something here. In these two systems, I'm seeing a 16y and a negative 16y. If you were to add these two things together, 16y plus, well, negative 16y is 0. If you make that observation, then the addition method works great. what you can do is add together the left and the right sides of the equations, term by term. So 2x plus 3x is 5x. I'll put it for emphasis, but 16y plus negative 16y is 0y. On the right side, we have 8 plus 12, which is 20. And really, I think it'd be fine to write 5x is equal to 20. You don't have to put the 0y in here. But if these two things are equal, and these two things are equal, and you add them together, these must be equal as well. So like very quickly, we went from these two equations to one equation with one variable. And this one is extremely easy to solve. If you want to solve for x, all you need to do is divide both sides by 5. And pretty quickly, we end up at our solution, which is 4. Well, at least the x value anyway. We need to know what the corresponding y value is. To figure that out, we can choose any equation we want. I'm going to choose this first equation. I'll put 4 in place of x and solve for the corresponding y. Here's what that looks like. 2 times 4 plus 16 times y is equal to 8. On the left, we have 8 plus 16y is equal to 8. If we subtract 8 from both sides, we get that 16y is equal to 0. And if we divide both sides by 16, no surprise here that we get y is equal to 0. This means there is exactly one solution to this system, and that solution has an x value of 4 and a y value of 0. And that is the one point that works for both equations. All right, let's use the addition method to solve this system of linear equations. But I'm noticing if you take the left and the right sides and you add them up, well, on the right side you get 3, that's not a problem, but on the left you get 4x and 5y. And while this is a true statement, it's not very useful. The goal is to try to cancel either an x or a y. So what we want are the numbers in front of the x's or the y's to be equal and opposite. So for example, if this were negative 3x, that would be perfect because negative 3x and 3x would give us 0x. If we want that to happen, what we could do is take the top equation and multiply both sides of it by negative 3. This is a completely valid step. If you do that, you get negative 3x minus 9y is equal to positive 3. So here I just simply took both sides of this equation and multiplied it by negative 3. And for the one below it, I'm just going to leave it alone. I'm not going to do a thing to it. I'm just going to say, well, that's 3x plus 2y is equal to 4. Okay, now if we add the two equations together, we do get 0x, which is perfect. I'm not going to write it. And when we add the y's together, we get negative 7y. And on the right side of the equation, we get a positive 7. So we just figured out that negative 7y is equal to 7. So sometimes a setup move will be necessary if you want to use the addition method. Anyway, to solve for y, not too bad. We can just take both sides of this equation and divide by negative 7. And we get y is equal to negative 1. So that's the corresponding y value. But we still need to know the corresponding x value. I think I'll take the top equation and put negative 1 in place of y. So that is, we get x plus 3 times negative 1 is equal to negative 1. So here I took this equation and put negative 1 in place of y. To solve for x, we get x minus 3 is equal to negative 1. If we add 3 to both sides, we get that x is equal to 2. And this means the solution is the point 2 for x, negative 1 for y. That's the only solution that we got, and that's the answer. So in each example that we looked at, there was always one solution to the system of linear equations. What about this system here? Negative 2x plus y is equal to 5, and then y is equal to 2x minus 1. Well, what about this thing? Now there's two ways we can solve this, either by using the addition method or the substitution method. I think we should use the substitution method, and the reason is this is solved for y, so we can directly plug 2x minus 1 in place of here. So that is, I'm taking this y and plugging it in to this y. when we do that, this is the equation that we get. 2x plus, okay, it's y, which is really 2x minus 1, and that's equal to 5. So this thing is now just 2x minus 1. And I don't even need the parentheses. So this is 2x plus 2x minus 1 is 5. Okay, some like terms on the left. Negative 2x and positive 2x is 0x. And, well, I'm not even going to write the 0x. So I'm just going to put negative 1 is equal to 5. And negative 1 is not equal to 5. That's false. This is not true. And if this isn't true, none of the previous steps are true. What this means is there is no solution. So if you go through this valid process of either the substitution or addition method and you end up at a false statement, something that's always false, that means there are no points that work. If we had something that was always true, well, then we'd say everything is a solution. The last thing I'd like to consider for this problem is, why did this happen? Is there some way to tell by looking at the equations to see that there is in fact no solution? Let's check that out on the last slide. So here we have the same system, but all I did was graph both of the lines. So here, this one in blue is y is equal to 2x minus 1. And the one that is in red, that's negative 2x plus y is equal to 5. These are parallel lines. In fact, the slope of both of them, they both have slope equal to 2. So they're parallel, meaning they move in the same direction, but they never intersect. Since these lines never meet, there's no point of intersection, and that means there is no solution to the system of equations.